Settle down, class. Today we're going to check out the European Space Agency's cluster mission. Now, does anyone know why it's called cluster? You're all half asleep this morning. Why don't you work together? See what you can come up with. All right, let's fly past and see if that helps.
There's 1, 2, 3, 4 satellites. So they're all part of the cluster mission.
That's right.
And they're called cluster because they're working together in a cluster?
You've got it. Finally. These satellites have been circling Earth for over a decade now. Each of them is about 3 meters wide and 1 meter high. The measurements they take from their individual positions mean scientists can build up 3-dimensional maps. They've got names too: Rumba, Salsa, Samba and Tango.
Well, I always said 2 heads were better than 1. And 4 heads are better than 2.
Yes, Quark, I've met your mum.
The cluster mission helps Earth scientists understand more about solar weather activity and its effect on Earth. Let's check out some of their discoveries.
Hey, look at the solar wind. It's like there's currents, like you get in the sea.
That's right. The cluster mission has found that there's turbulence in solar wind. And that's one reason why it keeps its energy even after travelling millions of miles. And if we fly past the North Pole, we can check another of its discoveries.
That's an aurora.
Aurora are the legendary red and green curtains that illuminate the long winter nights here at the Arctic Circle.
They're so beautiful.
Much less familiar are the strange black aurora, a strange electrical phenomenon that produces dark, empty regions within the visible northern and southern lights.
Black aurora. Sounds kind of spooky.
They're certainly mysterious. Black aurora take on various guises: dark rings, curls or black blobs in the sea of faint, glowing aurora.
So what causes them?
Well, the cluster missions figured out that these peculiar patches are caused by a kind of anti-aurora, where conditions are the exact opposite of those in the normal aurora. They seem to occur where there are holes in the ionosphere. That's the upper atmosphere, where the particles that make up the ionosphere are shooting upwards into space. This is the opposite process to that which creates visible aurora, where electrons spiral down from space into the atmosphere.
So it's not really an aurora at all. More of a missing part of an aurora?
That's right. Since it launched, the cluster mission has made dozens of discoveries, and by working together, those 4 satellites are providing super detailed maps of what's going on. Hey, didn't I tell you that working together is a great way to solve problems? Class dismissed.
Deep Space High, Intergalactic Weather Watch. With support from the Science and Technology Facilities Council. Find out more at funkidslive.com/space.